In this video, we are going to learn about creating and copying images. Here, we have created one demo instance. Now select it and go to Actions, click Image. Now let's say you have created this instance and added your customization. With this option, you can save it as your custom image. Let's see how this is done. Click Create Image. Give this image a suitable name and some description. If you enable no reboot option, it does not shut down the instance before making the image out of it. If this is disabled, the file systems on the machine and the image may not be guaranteed to be synchronized. For now, let's keep it disabled. Here, it has included the root volume by default. You can add additional volumes to the image if you wish. Click Create Image. If you click on this link, it will go to the AMI section and you can see that the current status of your image is pending. After a minute or two, the image should be ready. Our image is now ready. The status is available. It has all the details about the image, such as the source, which is your account ID, the image name, the visibility is currently private, the creation date, platform, root device, virtualization, etc. Now click Permissions. Here you can add the AWS account numbers to which you wish to give the permissions. Only these accounts would be able to launch instances from this image. Now note that by default the image is private. You can make it public here. Save it. You will have to refresh. And now this image is publicly visible. If you click on tags, you will realize that the tags are not copied from the instance to the image, but you can add few if you wish. Now note that we have created this image in the Ohio region. Now if you go to instances and try to launch a new instance, you can go to My AMIs and you can see that the newly created image appears here. If you select it and click Review and Launch, it will launch the instance using this image. Now, as I mentioned, the AMIs are region specific. That is, an AMI created in one region will not be available in other. If you change the region to say North Virginia, try to launch an instance and you can see that the image is not there. If you want our image to be available in this region, you will have to use copy image option on the AMI. Let's go back to our Ohio region. Go to AMIs, select the image, go to Action and click on Copy AMI. Now, some of the advantages of copying an AMI is consistency across global deployment of your application, increased scalability, high performance, and of course, high availability. Here you can select the destination region. I'm going to select North Virginia. You can rename this image. You can also change the description. The encryption option offers you to encrypt the snapshot at the target region even if it is not currently encrypted. If you choose to encrypt, the snapshot will be encrypted with the default keys. You can choose it to be encrypted or you can just disable it. I'm going to uncheck and say copy AMI. AMI copy operation has been initiated. You may have to refresh the AMI screen to see your new AMI. It can take few minutes until the new AMI is displayed. So let's go back to the North Virginia region. And you can see that the new image is in pending status and will be available shortly. After waiting for a minute or two, you can see that our new image or the copied image is ready. It will have the exact properties as that of the original image that we copied it from. Now let us see some of the important points related to AMIs and copying of AMI. The following table shows encryption support for various scenarios. If the snapshot of the AMI was unencrypted in the source region, it can remain unencrypted or it can be encrypted in the destination region. However, if the snapshot of the AMI was encrypted in the source region, it will remain encrypted in the destination region as well. You cannot copy an encrypted snapshot in the source region to become an unencrypted in the destination region. For more information, you can visit this website. Few things to remember about AMIs and copying of AMIs for the exam. All AMIs are categorized as either backed by Amazon EBS, that is the root device of the AMI is an Amazon EBS volume, or backed by Instance Store, that is the root device is an Instance Store volume which is created from a template that is stored in S3. There are no charges for copying an AMI. However, standard storage and data transfer rates do apply. AWS does not copy launch permissions, user-defined tags, or S3 bucket permissions from the source AMI to the new AMI. You can share your AMI with another AWS accounts. This is called as cross-account AMI copy. Now note that sharing an AMI does not affect the ownership of the AMI. The owning account is still charged for the storage in the region in which the AMI resides. You can deregister an AMI when you are finished using it. After you deregister an AMI, you cannot use it to launch new instances. However, deregistering an AMI does not affect any instances that were already launched from it. In this video, we are going to learn about volumes and snapshots, and this is a very important topic. Let us see what an EBS volume is. Quite simply, it is a durable block-level storage device that you can attach to a single EC2 instance. Note the word durable here. Whereas a snapshot is a point-in-time backup of the data that is stored on the EBS volume. EBS volume is durable. In the sense, even if you stop the instance or shut down the operating system on it, you will not lose the data. The data is persisted until you either delete the volume or terminate the instance. And I'm assuming that delete on termination flag is unchecked. EBS volume is mostly used as the primary storage for data that requires frequent updates, such as the system drive of the instance or even storage for a database application. It is flexible. That means you can dynamically increase the size or modify provisioned IOPS capacity and change volume type on live production volumes. This is important to remember. You no longer have to stop the instance in order to change the volume type or size. There are two types of EBS volume. For root volume, you can select general purpose SSD, that is solid state drive, provisioned IOPS SSD, or magnetic HDD, that is hard disk drive. We saw this during the creation of the EC2 instance. For other volumes, you can use throughput optimized HDD or cold hard disk drive. An important thing to remember is that an instance can have multiple volumes attached to it. However, you can attach one EBS volume to one instance at a time. That is, you cannot share a volume among multiple instances. You can detach the volume and attach it to another instance if you wish. After a volume is attached to an instance, you can use it like any other physical hard drive. Now let us see some of the advantages of using EBS volume over, say, instance store volume. Data availability. When you create an EBS volume in an availability zone, it is automatically replicated within that zone for high availability. This helps preventing the data loss due to failure of any single hardware or hypervisor. Now remember that EBS volume and the instance to which it is attached must be in the same availability zone. Data persistence. An EBS volume data can persist independently from the life of an instance. EBS volumes can have their data intact when that instance is terminated. The volume can be reattached to a new instance, enabling quick recovery. Remember that by default, EBS volumes that are created and attached to an instance at launch are deleted when that instance is terminated. You can modify this behavior by changing the delete on termination flag when you launch the instance. If you are using EBS backed instance, you can stop and restart that instance without affecting the data stored on that attached volume. The volume remains attached throughout its stop and start cycle. The data persists on the volume until the volume is deleted explicitly. If you are dealing with some sensitive data, you should consider encrypting your data manually or storing the data on a volume that is protected by Amazon EBS encryption. With data encryption, for simplified data encryption, you can create encrypted EBS volumes with the Amazon EBS encryption feature. Amazon EBS encryption uses 256-bit Advanced Encryption Standard Algorithm, in short AES 256. It is very important that you remember this for the exam. Amazon EBS encryption uses AWS Key Management Service or AWS KMS master keys when creating encrypted volumes and any snapshots that are created from your encrypted volumes. Backup or snapshots. Amazon EBS provides the ability to create snapshots, that is, a point-in-time backups for any EBS volume and write a copy of the data in the volume to Amazon S3. In Amazon S3, it is stored redundantly in multiple availability zones. The data can be backed up or the snapshot can be taken even when the volume is attached to a running instance. These snapshots can be used to create multiple new EBS volumes or move the volumes across availability zones. Remember that snapshots of encrypted EBS volumes are automatically encrypted. Similarly, the EBS volumes that are restored from encrypted snapshots are automatically encrypted as well. Now, one thing to note is that snapshots are incremental backups, meaning that only the blocks on the volume that have changed after your most recent snapshot are saved. Even though snapshots are saved incrementally, the snapshot deletion process is designed so that you need to retain only the most recent snapshot in order to restore the volume. Finally, EBS volumes are flexible. That means they support live configuration changes while in production. You can modify volume type, volume size, and IOPS capacity without any service interruptions. Now let us see how the volumes are created and attached to an instance in AWS Console. In the AWS Console, go to EC2, go to Running Instances. Now here I have created two instances for this demonstration, Demo 1 and Demo 2. Now go to Volumes. There are two volumes corresponding to those two instances. Let's select Demo 1, click on Actions, click Detach Volume. Here you will get an error saying root volume cannot be detached. Even if you try to detach it explicitly, it is not going to detach it. Click Cancel. Now click on Create Volume. We have already seen these options during the creation of an EC2 instance. Remember that the volumes and the instance need to be in the same availability zone. For us, it was US East 2B. So let's go ahead and select that. Here, you can select Snapshot ID. You can search for public snapshots to create the volume from. Remember that the volumes created from encrypted snapshots are automatically encrypted and vice versa. Just keep all other options as they are. Let's add a name tag. Click Create Volume. Once created, it will have a status as available. Select it and click on Actions. Now you can modify it or take a snapshot from it or just delete it. These options are fairly self-explanatory. Now click on Attach Volume. Here you can search for the instance to which you want to attach this volume. Let's select demo 1. It is going to automatically attach the device based on the operating system of the instance. Click attach. Now once done, the status should change from available to in use. To verify that the volume was really attached, go to instances, select demo 1, and here you can see that it has two block devices attached. This one is the demo volume. You can verify that by clicking on it. Now go back to volumes, select the demo volume, actions, and detach volume. And now you should be able to detach the volume. Once you refresh, the state of this volume now should be changed back to available. Now attach this to demo 2. Once the status goes back to in use, go to instances, click on demo 1 and verify that it has now only one block device. And demo 2 has two of them. Now let us see some important points about snapshots. As mentioned earlier, a snapshot is a point-in-time backup of the data that is stored on the EBS volume. Each snapshot contains all the information needed to restore your data from the moment when the snapshot was taken to a new EBS volume. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshot are saved. This minimizes the time required to create the snapshot and saves on storage cost by not duplicating the data. When you delete a snapshot, only the data unique to that snapshot is removed. With EBS snapshots, you need to understand about lazy loading. When you create an EBS volume based on a snapshot, the new volume begins as an exact replica of the original volume that was used to create the snapshot. The replicated volume loads the data lazily in the background so that you can begin using it immediately. That means not all the blocks are loaded immediately. If you access the data that hasn't been loaded yet, the volume immediately downloads the requested data from Amazon S3 and then continues loading the rest of the volume's data in the background. A snapshot is constrained to the region where it was created. The volume can be created in the same region only. As we saw in one of our earlier demonstrations, the snapshots support cross-region copy. With respect to encryption, just remember that snapshots of encrypted volumes are automatically encrypted. Similarly, volumes that are created from encrypted snapshots are automatically encrypted as well. When you copy an unencrypted snapshot that you own, you can encrypt it during the copy process. And finally, when you copy an encrypted snapshot that you own, you can re-encrypt it with a different key during the copy process. In the AWS console, go to EC2, click on Snapshots, click on Create Snapshot. Here you can select the volume from which you wish to create the snapshot. Go ahead and select the volume. You can give it a description. Now since the volume was not encrypted, this snapshot will not be encrypted either. Now you can attach some tags to this snapshot. And click Create Snapshot. Now here the status is pending and you can see the current progress using this progress bar. Once the snapshot is created, the status will become completed. If you select it and go to Action, you can delete the snapshot or create a volume or image from the snapshot. In this video, we learn about EBS volume and snapshots. It is very important that you remember these points for the exam. For further understanding, try to create new volumes attached to running and stopped instances. Try to create snapshots and copy them to another region. Observe the encryption settings. I am sure by this time you will be able to tackle any question on any EC2 related topic. Good luck, and I will see you in the next section. Thank you. Hi there. In this video, we are going to learn about instance store and placement groups. Note that these two topics might not be directly related to each other, but they are important and frequently appear on the exam. Let us first see what an instance store is. An instance store provides a temporary block level storage for your instance. This storage is located on disks that are physically attached to the host computer. Mark the word temporary here. Placement group. A placement group basically determines how the instances are placed on the underlying hardware or hypervisor upon launching. There are two types of placement groups. Cluster, in which all the instances are launched on a single hypervisor and spans a single availability zone. Spread placement group, in which the instances are spread across different hypervisors and different availability zones. Let us see some of the important points related to an instance store. As mentioned earlier, it provides a temporary block level storage for your instance. That is, it is ideal for temporary storage of information that changes very frequently, such as buffers or caches, scratch data, and other temporary content. Instance store disks are physically attached to the host computer. However, you cannot detach instance store volume that is attached to an instance and attach to a different one. You could do this with EBS volumes, but not with the instance store volume. The data in an instance store persists only during the lifetime of its associated instance. If an instance reboots, intentionally or unintentionally, the data on the instance store persists. However, if the instance stops, terminates, or the underlying disk drive fails, the data on the instance store is lost. Therefore, you should not rely on an instance store for valuable long-term data. Instead, you should be using more durable storage options such as S3, EBS, or Elastic File System. An important point to remember is that if you create an AMI from an instance with instance store, the data on its instance store volume isn't persisted, and it will not be present on the instance store volume of the instance that you launch from the AMI. This behavior is different with EBS, where the data will be persisted on the instances that are launched from the AMI. Now let us learn more about the placement group. A placement group basically determines how the instances are placed on the hypervisor upon launching. There are two types of placement groups as I mentioned, cluster and spread, which we will see in details in next slide onwards. Note that there is no charge for creating a placement group, but of course you will be charged for the instances that you would launch in them. In cluster placement group, instances are launched in a low latency group on a single underlying hardware in a single availability zone. You need to launch the instances that support enhanced networking. While we were launching the EC2 instances, we noticed that there are certain instances which support this option. You need to use those here. It is recommended that you launch same type of instances all at the same time. If you don't, that is, if you try to add more instances to an existing placement group, or if you try to launch more than one instance type in the placement group, you might get an insufficient capacity error. This is important to remember. If you stop an instance that is part of a placement group and then start it again, it still runs in the placement group. However, the start will fail if there isn't enough capacity for that instance. And if you receive a capacity error when launching an instance in a placement group that already has some instances running, just stop and start all the instances in the placement group and then try to launch them again. This is recommended by AWS. On the other hand, in spread placement group, each instance is launched on a separate hypervisor in different availability zones. As a result, it reduces the risk or impact of underlying hardware failure. Since the instances are launched on different hardware, it allows you to launch instances of different type and at different time. The instances that are launched as part of this placement group can span different availability zones, but remember that maximum 7 running instances per availability zone per group is allowed. If you try to launch an instance and there is no unique hardware available, your request will fail. AWS recommends that you launch the instance after some time in this particular case. Finally, spread placement group is not supported for dedicated instances or dedicated host options. Now let us see how these options are used in the AWS console. In AWS console, go to EC2, click on Launch Instance. Here, click on Community AMIs. Down here, you can select Instance Store, and it should show only those AMIs that will launch EC2 instances backed by the instance store volume. Just note that after launching the instance, if you stop and start it, you will lose the data stored on the instance store volume. Now click Select, click Configure Instance Details. Here you can see the placement group option. You can select existing placement group or add instance to a new placement group. Select Add to a new placement group and give it a name. It gives you different group strategies, cluster and spread. You can select the one you wish. The rest of the process of launching the instance is same as EBS, which we have seen in the previous videos. With this video, I hope you understood the concept of instance store and placement group. I will see you in the next video. Thank you. Alright, let's summarize what we learned in this entire EC2 and EBS topic. First, we got introduced to EC2, which is part of compute section of Amazon Web Services. Then we learned about the benefits of using EC2. We started our journey by creating an EC2 instance and along the way learned quite a lot of concepts that are associated with it. We first studied about Amazon Machine Image or AMI. We learned about EC2 instance and instance types such as general purpose, compute optimized, GPU graphics, GPU compute, memory optimized, and storage optimized. Quite honestly, you do not need to remember their acronyms or the letter which it represents. You just need to remember which is used for what purpose. We also learned different purchasing options such as dedicated, reserved, scheduled, spot, dedicated instance, and dedicated host. Among those, spot instance is a very important subtopic. Remember how its pricing works. Important to note that you are not billed for the partial hour of usage if the instance gets terminated due to the spot price increase. Along the way, we touched the topic of VPC, that is Virtual Private Cloud, and subnets. About security groups, remember that they are stateful. We also learned about elastic IP addresses, that is EIP, and elastic network interfaces, which is ENIs. We also learned about placement group, which is of two types, cluster and spread. We also learned about what a key pair is and why it is used. We also saw how it is used. In elastic block storage, we learned about what elastic block storage is and how it works. We learned about different types of it. For root volume, general purpose SSD, provisioned IOPS SSD, and magnetic HDD, that is hard disk drive. For other volumes, we learned about throughput provisioned HDD and cold HDD. We learned each option in details. We learned about EBS volume and snapshots. We saw some very important points regarding those which are very important for the exam. And finally, we learned what an instant store is and how it is different than EBS.